let's try to get an idea of what we're doing for Lab 4. We're going to do Lab 4 in two parts. So the first part is in this worksheet over here. Let me open up one of them. I'll open up the PDF. So I have a PDF and a Word document of part 1 of Lab 4. So the shaded boxes are the things that you would fill out before coming to lab, if we were coming to lab, these ones anyway. You would calculate the mass of cobalt-2 nitrate hexahydrate that you need to make 50 milliliters of a 0.20 molar solution. Also the copper-2 sulfate pentahydrate you need to make 50 milliliters of a solution that is 0.12 molar in copper-2 sulfate pentahydrate. So these two substances are going to be both mixed in the 50 milliliter solution, but at different concentrations. So you're going to provide the molar mass and the grams needed. We talked about this a little bit in class on Tuesday. All right. So then once you have a target mass, and again that's about a 2 significant digit is how you're doing these calculations because of the molarities, then choose an actual mass that you get to lab, you weigh out the mass, but it's not an exact match. It's within 0.12 grams of what you wanted, but you didn't want to stay at the balance all day, going back and forth, scooping it in and out of the balance, so you just got close, but you didn't get an exact match. So we're going to pretend that you actually went to lab and got a mass of cobalt-2 nitrate hexahydrate and a mass of copper-2 sulfate pentahydrate. So these should be close, the actual mass you use should be close to what you wanted to get, but not an exact match. Same thing with the copper, it should be close to this number, but not an exact match. So the first thing that you would do is to weigh out the desired amount of copper-2 sulfate pentahydrate and cobalt-2 nitrate hexahydrate into some beakers. And you could zero the beaker on the balance. So you would just zero it and then weigh out the proper amount. I'm not going to show you how much is in here. I'll just go ahead and scoop some. I'll get that out later. Okay. And then you would weigh it again. Again, this is not the right amount, but at this point you would know that you have 0.968 grams of copper-2 sulfate pentahydrate in your beaker. The cobalt-2 nitrate hexahydrate is kind of stickier, so just to let you know how that is. It's kind of hard to scoop out. Let's see if can I show it inside there? So it's kind of chunky and clumpy and sticky. Alright, I found that the copper-2 sulfate is somewhat crystalline. So a lot of times most of it can just go down the funnel into the volumetric flask here. For the cobalt-2 nitrate hexahydrate, it's kind of sticky and clumpy, so it doesn't go down the funnel that well, but luckily it dissolves in water pretty easily. So dissolving it first is the way to go with that one. And then just rinsing the beakers until you're sure that you've transferred all of the material into the volumetric flask. So a couple of rinses, maybe even a rinse with the copper beaker would be a good idea. All the stuff that you weighed out should go into your volumetric flask. So I've just rinsed them until all of the colored material is out of the beakers and in the volumetric flask. And now before filling it up to the line with water, you want to make sure that all of the solid is dissolved. That takes a minute, so I will pause this. So once all the solid has dissolved, you need to fill it up with water just to that line. If you can see the line. There you go. So that's the line that you're trying to hit. And so the last few drops, you probably want to use a dropper so that you don't go past the line. Otherwise, you do not have 50.00 milliliters of solution.
so exciting.
Oh, there we go. Okay. Now you'll notice the stuff in the neck is not as concentrated as the rest, so we want to stop her and invert it a few times to mix. All right, then once you make up your solution, you would have 2 burettes, one with the stock solution you just made up that has copper and cobalt salts in it, and then one of just deionized water, so purified water that does not have anything in it except water. And so for test tube 1, you're supposed to have about 1 milliliter of stock and 4 milliliters of water for a total volume of about 5. Again, when you do this in lab, you don't always get 1.00 and 4.00 and 5.00, so I want you to put realistic numbers that are close to 1. Maybe you got 1.02 milliliters, maybe you got 0.98 milliliters, but I want you to make up numbers that are not exact, but close to your targets. Also, these burette readings, since we're doing this with a burette, they should go 2 places past the decimal. So hopefully these instructions in red can also help out. Okay. Then once you've put all these shaded boxes in here, I will be basing the absorbance readings on what you have done so far. So I will be providing the data that you got in lab based on how you made up your solutions. This is also needed for part 1, calculating the actual molarity concentration of your stock solution. Okay, so remember the actual amount you used is not an exact match with your target value, and also the amount you use should end up with 4 significant digits, not your target, which only has 2 significant digits. So I want you to recalculate the actual molarity based on the actual mass that you say you used. Okay, and then I included some other things that you're going to need for the rest of the report. This doesn't need to be in part 1. I just decided to include the rest of the lab just so that you have it all in one place. Now I've transferred the solution to a beaker because it is very difficult to pour from a volumetric flask. And this burette might not be completely clean, so we want to rinse with the solution a couple of times first, just a little bit of the solution. So a small amount of solution, and then rotated, and make sure all the walls are coated with the proper solution and not water or some other thing. You don't want to fill it up several times, you just want to put a little bit to rinse it several times, otherwise you will run out. So maybe 3 times total. And once you're done with a few rinses, you can fill up the burette with the solution that you are using. And then also be sure to open the stopcock so that the part below the stopcock is filled with the solution you want as well. So now we have 1 burette with our copper and cobalt solution and 1 burette with just DI water. So for each of our test tubes, we are going to dilute this stock solution. This is the one that we made. This is DI water. So the process would be to read the volume on the burette, then to dispense approximately the amount you want. Let's say for the first test tube, we want about 1 milliliter. So we dispense about 1 milliliter in there. Read it carefully again. Move the test tubes over here. Now we have some water. We would read the burette. Then we want to dispense about 4 milliliters of water. And then we would read the burette again. And then we would be able to calculate the concentration of our diluted solution in test tube 1. And we would repeat that process for the other 4 tubes. For each solution that we've made, we're going to transfer it from the test tube into the cuvette and put it into the spectrophotometer and scan it. Along the x-axis is the wavelength that's being scanned, and along the y-axis is the absorbance that we're going to measure. So we want to know what the absorbance is at the peak, the first peak, that is close to around 515 nanometers. So we're recording at 515 nanometers, the absorbance is 0.374. If we had a greater concentration of cobalt, we would have a greater absorbance than 0.374. If we had less, then there would be less. Then for the second peak, we want to find where we're getting the peak absorbance here. It looks like it's around 815 nanometers, and the absorbance is 0.925. If there were greater amount of concentration of copper in there, the absorbance would be more, and if there were less, it would be less. And so you record the absorbance for each of your test tubes, and that's what data you're being provided.